We have our capacitors, the 50, 30, 36, and 12. We want to know the total energy stored by this 36 microfarad capacitor. Energy, we need to know any two of the three possible things. We need to know capacitance, which conveniently we know, and we either need to know charge or potential difference. One of the two will give us the energy. Now we have to combine this because we don't know how much voltage or charge any of these have. If we were to take a path around our circuit, if we leave the battery, we have a choice to go through either the 50 or the 30. So that makes both the 50 and the 30 in parallel. So the 50 and 30 are combined in parallel. But then as we continue on, we then have the choice to go between either the 36 or the 12. The combination of these two is in series with the combination of these two. So in parallel, the 50 and the 30 would be equivalent to an 80 microfarad capacitor. The 36 and the 12 would be equivalent to a 48 microfarad capacitor. They're still connected to a 30-volt battery. So the 80 and the 48 are in series because if we follow a path around the loop there, we have to pass through both of them. So they're equivalent to one capacitor. 1 over C equivalent is 1 over 80 plus 1 over 48. Chugging that through the calculator, the equivalent capacitance is 30. Battery is 30 volts. So the total charge is the equivalent capacitance times the total voltage. So the 30 microfarads times the 30 volts. So 900 microcoulombs is the total charge. Working our way back, since those two are in series, we know that both of these have to have 900 microcoulombs of charge. Now, the only one we care about is this one, because this one is where our 36 microfarads is up, or included. So we can find delta V here. Delta V is Q over C. Our charge is 900, our capacitance is 48. So we get 18.75 volts. But the 48 microfarad capacitor was equivalent to the 36 and 12 in parallel. In parallel, they have to have the same voltage. They have to have that 18.75 volts. So both of them have 18.75 volts. All we care about as far as this question is concerned, though, is this guy. The question wants to know how much energy this capacitor stores. So we need the value of its capacitor and the value of its voltage drop. So 1/2, its capacitance is 36 microfarads. Its voltage is 18.75 volts. Need to square that. Plugging in 10 to the negative 6 for micro, we get 6.3 times negative 10 to the negative 3 joules, which is the same thing as 6.3 millijoules would work, or 6,300 microjoules. If you left it as micro, is fine as well. So you had to work your way all the way down and then work back until you had enough information about the one capacitor. We could certainly find charge and energy and voltage for each of the capacitors if necessary, but to solve this particular problem, we only needed it for the 36. Any questions?